Hello and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we go back to January 31st, 1958. A cold winter evening at Cape Canaveral, Florida. Floodlights illuminate Launch Complex 26, where a slender rocket stands 71 feet tall. For 90 days, America has waited, humiliated by Soviet success, wounded by the Vanguard explosion. Tonight, Explorer 1, a pencil-thin satellite weighing just 30.66 pounds, will make history not through propaganda, but through discovery. James Van Allen's cosmic ray detector aboard will reveal Earth's invisible radiation belts, the first major scientific finding of the space age. So settle into comfort, close your eyes, and let this story of patience, precision, and scientific triumph carry you gently towards sleep. Before we begin this journey through history, let's prepare your body and mind with some gentle breathing. We'll use a countdown rhythm, just like the engineers at Cape Canaveral that night. Breathe in deeply as the countdown begins. 10, 9. Breathe out slowly. 8, 7. Breathe in as systems check. 6, 5. Breathe out peacefully. 4, 3. Breathe in as engines ignite. 2, 1. Breathe out as Explorer rises. Each breath like orbital motion, ascending, circling, discovering. It's January 31, 1958. At 10:48 p.m. Eastern Time. Launch Complex 26 at Cape Canaveral Air Force Station, Florida. A slender rocket stands 71.3 feet tall beneath the gantry. This is the Army's Jupiter C rocket, barely one-third the height of the mighty Soviet R-7 that launched Sputnik. Atop this modified ballistic missile sits Explorer 1, America's first satellite. A pencil-thin cylinder just 80 inches long, 6.25 inches in diameter, painted in alternating white and dark green stripes, weighing exactly 30.66 pounds. Tonight marks the end of 90 days of waiting. October 4th, 1957. That's when Sputnik launched. The Soviet Union's 184-pound sphere shocked the world with its simple beeping radio signal. Just 30 days later, November 3, Sputnik 2 carried the dog Laika into orbit. America watched in dismay. Fear spread through the nation. The missile gap dominated headlines. If the Soviets could orbit satellites, they could deliver nuclear warheads anywhere on Earth. American pride was wounded. Educators panicked about science education. The military scrambled. President Dwight Eisenhower remained publicly calm, but privately concerned. The administration had made a critical choice back in July 1955. America would launch its first satellite using the Vanguard program, a civilian scientific effort led by the Naval Research Laboratory. 3-stage rocket, minimal payload, pure science. This decision was deliberate. Eisenhower wanted to separate space exploration from military missile development. He wanted the world to see America's peaceful intentions. But Vanguard wasn't ready. And after Sputnik, the world was watching. needed to respond quickly. December 6th, 1957. 2 months after Sputnik, Vanguard was ready for its first orbital attempt. The test vehicle, designated TV-3, stood on the launch pad at Cape Canaveral. National and international media gathered. Cameras were rolling. The entire world watched America's answer to Sputnik. 11:45 a.m. Eastern Time. The rocket ignited. It rose exactly 4 feet. Then it lost thrust. The rocket settled back onto the pad. Fuel tanks ruptured. A massive fireball engulfed the launch complex. Vanguard TV-3 exploded in front of the world. The tiny 3.25-pound test satellite was thrown clear by the explosion. Remarkably, it survived. Its transmitter briefly functioned, beeping pathetically from the wreckage. The press had a field day with cruel nicknames: Flopnik, Kaputnik, Stay Putnik, Oopsnik. Soviet Premier Nikita Khrushchev mocked America openly, offering technical assistance, like we give to underdeveloped countries. The humiliation was complete. That little satellite now rests in the Smithsonian National Air and Space Museum, a memorial to national embarrassment, but also to persistence. The cause of the TV-3 failure was eventually determined. A fuel line ruptured at liftoff due to pressure fluctuation. An engineering issue, fixable, but the damage to American pride was severe. Vanguard would try again. February 5, 1958, Vanguard TV-4 launched. It failed at 57 seconds when the nose cone separated prematurely. 2 failures. America remained grounded while Sputnik circled overhead. But there was another option. The Army had been waiting. Wernher von Braun's team at Redstone Arsenal in Huntsville, Alabama had a rocket ready. They'd been ready since 1956. Wernher von Braun was 45 years old in 1958. A German rocket engineer who had developed the V-2 rocket for Nazi Germany at Peenemünde during World War II. In 1945, Operation Paperclip brought him and his team to the United States. They surrendered to American forces, bringing their knowledge and experience. For over a decade, von Braun worked for the U.S. Army, developing ballistic missiles. The Jupiter C rocket was their creation. On September 20th, 1956, a Jupiter C test flight reached an altitude of 682 miles. It could have orbited a satellite. But von Braun had been specifically ordered not to orbit anything. Eisenhower's decision to prioritize Vanguard meant keeping the Army's missile program on the ground. Von Braun's frustration must have been immense. He had the capability. His team was ready. But politics required waiting. After Sputnik, after the Vanguard explosion, everything changed. November 8th, 1957, the Pentagon issued new orders. The Army Ballistic Missile Agency was authorized to proceed immediately. Von Braun's team would launch America's satellite. They had exactly 84 days to prepare the rocket and satellite. 84 days from authorization to launch. The crash program began. The clock was ticking. The Army team assembled quickly at Redstone Arsenal. Wernher von Braun led the Army Ballistic Missile Agency, responsible for the Jupiter C rocket itself. Dr. James Van Allen, age 43, was a physics professor at the University of Iowa. For years, he'd pioneered raccoon experiments, launching instruments on rockets carried aloft by balloons. He'd studied cosmic rays since flying experiments on captured German V-2 rockets in the late 1940s. Van Allen would provide the scientific instruments for Explorer 1. His cosmic ray detector would ride inside that narrow cylinder. William Pickering, age 47, directed the Jet Propulsion Laboratory at Caltech. Pickering's JPL was responsible for the upper stages of the Jupiter C rocket and the satellite itself. General John Medeiros commanded the Army Ballistic Missile Agency and championed the Jupiter program politically. These four men, von Braun, Van Allen, Pickering, and Medeiros, formed the core leadership. Behind them stood hundreds of engineers, technicians, and scientists working around the clock. 84 days to assemble a rocket. 84 days to build and test a satellite. 84 days to prepare launch facilities. 84 days to restore American pride. The work progressed methodically despite the urgent deadline. Careful assembly, patient calculation despite urgency. The Jupiter C rocket, officially designated Juno 1 for the satellite mission, was a multi-stage vehicle. The first stage was a modified Redstone ballistic missile, a single engine producing 83,000 pounds of thrust, burning a mixture of alcohol and liquid oxygen. The upper stages used clusters of small Sargent solid fuel rockets. 11 Sargents formed the second stage. 3 Sargents formed the third stage. A single Sargent rocket formed the fourth stage. Explorer 1 sat atop that final stage. At launch, the entire vehicle weighed 64,000 pounds. Small, compared to the Soviet R-7's massive weight. But capability matters more than size. Explorer 1 itself was a marvel of compact engineering. That cylinder, 80 inches long and 6.25 inches in diameter, contained remarkable instrumentation. James Van Allen's primary experiment was a cosmic ray detector, a Geiger-Müller tube, specifically a Type 302 Geiger counter. It was designed to measure between 30 and 50,000 counts per second. The satellite also carried 2 radio transmitters, operating at 108.00 and 108.03 megahertz. 4 fiberglass whip antennas, each 45 inches long, would broadcast telemetry to tracking stations. Mercury batteries would provide power for approximately 60 days. The satellite would spin at 750 revolutions per minute for stability. January 29, 1958, the first launch attempt. The Jupiter C stood ready at Launch Complex 26. Weather reports showed high-altitude jet stream winds exceeding safe limits. The launch was scrubbed. America waited another day. January 30, the second attempt. Technical issues emerged during final checks. Scrubbed again. The nation's anxiety grew. Would this be another Vanguard? Another failure in front of the world? Von Braun's team worked through the night, checking every system. January 31st arrived. Weather cleared. Technical systems checked out. The decision was made to proceed. Tonight would be the night. Launch Complex 26 at Cape Canaveral stood illuminated by floodlights as evening approached. The gantry tower surrounded the slender Jupiter C. Technicians performed final checks. Fuel loading proceeded carefully, alcohol and liquid oxygen flowing into the first stage tanks. The upper stage Sargent rockets were already loaded with solid propellant. Explorer 1, secured at the top, had been powered up and tested. Van Allen's Geiger counter was functioning normally. Radio transmitters were broadcasting test signals. Tracking stations across the United States and around the world were ready. The countdown entered its final phase. 10:48 p.m. Eastern Time approached. America held its breath. Inside Explorer 1, Van Allen's instruments were recording ambient radiation levels. The satellite's internal temperature was monitored continuously. During orbit, it would experience extremes, varying from -40 degrees Fahrenheit to +105 degrees. The satellite was painted in those alternating white and dark green stripes, not just for visibility, but for thermal control. White stripes would reflect sunlight. Dark stripes would radiate heat. The spinning motion at 750 RPM would distribute heat evenly around the cylinder. Every detail had been considered. This was 84 days of compressed engineering, years of accumulated knowledge, decades of rocket dreams, all riding atop 71.3 feet of precisely assembled metal. The weight difference between Explorer 1 and Sputnik was significant. Sputnik 1 had weighed 184 pounds, 6 times heavier than Explorer's 30.66 pounds. Of Explorer's weight, the satellite structure itself accounted for only 12.31 pounds. The scientific instrument payload weighed 18.35 pounds. Van Allen had packed as much instrumentation as possible into that narrow space. The satellite's shape, that long, thin cylinder, was dictated by the small diameter of the fourth stage Sargent rocket. There was no room for spheres or elaborate structures. This was efficient, compact, purpose-built engineering. Every ounce mattered. Every inch was utilized. Form followed function. Science would ride to space in minimal packaging. As 10:48 p.m. arrived, the countdown reached 0. The modified Redstone first stage ignited. Flames erupted from the engine bell. Steam and smoke billowed across the launch pad. Unlike Vanguard TV-3, the Jupiter C held steady. Thrust built to 83,000 pounds of force. The rocket lifted smoothly. 71.3 feet of metal rising into the Florida night sky. Tracking cameras followed the ascent. The alcohol and liquid oxygen burned in controlled fury. The first stage would burn for approximately 2.5 minutes, carrying the rocket and its precious payload toward space. Rising through the atmosphere, accelerating, climbing toward orbit. At altitude, the first stage separated cleanly. The second stage cluster ignited. 11 Sargent solid rockets firing together, each small motor contributing thrust. The combined cluster accelerated the upper stages and Explorer 1 further. Second stage burnout came quickly. Solid rockets burned fast and hot. Third stage separation. 3 Sargents firing now. Higher, faster. Third stage burnout. Finally, the fourth stage. A single Sargent rocket with Explorer 1 attached. This final burn would determine orbit. Velocity had to be precise. Approximately 18,000 miles per hour to achieve orbital insertion. The fourth stage fired. Total flight time to orbital insertion was approximately 13 minutes from liftoff. Now came the anxious wait. To confirm orbit, Explorer 1 had to complete a full revolution around Earth. The satellite's orbital period was calculated to be 114.8 minutes. Von Braun's team at Cape Canaveral monitored communications. James Van Allen waited at Jet Propulsion Laboratory in Pasadena, California. William Pickering coordinated tracking stations. The California tracking station at Earthquake Valley would receive the first signal when Explorer 1 passed overhead. But that pass wouldn't come for over 90 minutes. The satellite had to cross the Atlantic Ocean, pass over Africa, traverse the Indian Ocean and Pacific, approaching California from the west. 90 minutes of tense waiting. The minutes passed slowly at JPL. No signal yet. Was Explorer 1 actually in orbit? Had the fourth stage achieved proper velocity? Or had something failed? The calculations said the satellite should appear overhead soon. Tracking operators watched their instruments intently. Van Allen waited. Pickering waited. The nation waited. Then, at 12:41 a.m. Eastern Time on February 1, 1958, Earthquake Valley received a signal. Goldstone has the bird. JPL erupted in celebration. Explorer 1 was in orbit. America had answered Sputnik. Telemetry began flowing to tracking stations. The satellite's orbit was quickly calculated from the radio signals. Perigee, the lowest point, was 220 miles above Earth, lower than planned. Apogee, the highest point, was 1,575 miles, much higher than expected. Higher than Sputnik's 583-mile apogee. Orbital period confirmed at 114.8 minutes. Inclination, 33.24 degrees. Both transmitters at 108.00 and 108.03 megahertz functioning normally. The satellite spun at 750 RPM as designed. Everything was working perfectly. America was finally in space. At 2:30 a.m., the Pentagon assembled a press conference. 3 exhausted but elated men appeared before cameras. Wernher von Braun in a suit, tired but smiling. William Pickering, composed and scientific. James Van Allen, holding a cigar, grinning broadly. The famous photograph captured this moment. The 3 men held a replica of Explorer 1 overhead in triumph. That image would become iconic. Just 8 weeks after Vanguard's explosion, America had succeeded. Von Braun spoke simply. Explorer is up there and going around the Earth. American pride began to return. Dawn broke over the East Coast. Newspapers prepared front-page headlines. U.S. satellite in orbit. European morning papers reported American success with respect. The Soviet press acknowledged the achievement. Scientists worldwide congratulated Van Allen and the team. Amateur radio operators began tracking the signals. Visible passes were calculated for observers. Explorer 1 weighed 30.66 pounds, heavier than Vanguard's 3.25 pounds, but still smaller than Sputnik's 184 pounds. But the weight didn't matter. America was finally in space, and real science was about to begin. Van Allen's cosmic ray detector was transmitting data continuously. Geiger counter measurements were recorded at tracking stations during each orbital pass. The instrument measured radiation from 30 to 50,000 counts per second. At low altitudes near perigee, readings showed expected cosmic ray levels. A few hundred counts per second, consistent with previous balloon and rocket experiments. But something strange appeared as Explorer 1 climbed toward apogee. At higher altitudes, the readings suddenly dropped to 0. This puzzled Van Allen's team. Was the instrument failing? Or was something else happening? At first, they suspected instrument failure. Perhaps the Geiger counter malfunctioned. Perhaps the electronics couldn't handle temperature extremes. But the pattern was consistent and repeating. At perigee, 220 miles altitude, normal cosmic ray levels. As Explorer 1 climbed toward 1,575 miles apogee, readings climbed too, then suddenly dropped to 0. They remained 0 for several minutes. As the satellite descended toward perigee again, readings returned to normal. Orbit after orbit, the same pattern. Normal, rising, 0, normal again. What could explain this? James Van Allen studied the data carefully. A hypothesis began forming. What if the counter wasn't failing? What if it was overwhelmed? Geiger counters have a maximum detection rate. Above a certain radiation intensity, they saturate. When saturated, they can register 0 instead of maximum, like a camera overexposed by too much light appearing black. If radiation levels exceeded the counter's 50,000 counts per second maximum by a substantial margin, saturation would occur. That would produce exactly the pattern they were seeing. 0 readings might actually indicate extremely high radiation. Van Allen's hypothesis was bold. It suggested Earth was surrounded by regions of intense radiation at altitude, far more intense than anyone predicted. But he needed proof. He needed an instrument with wider detection range or a way to record complete data. Another satellite mission was needed. Explorer 2 launched on March 5, 1958, but failed to achieve orbit. The wait continued. Van Allen prepared an improved instrument package. This time, the satellite would carry a tape recorder. It could store data during entire orbits for later playback. March 26, 1958, Explorer 3 launched successfully. It carried Van Allen's improved detector and a magnetic tape recorder. Orbital period was 115.9 minutes, very similar to Explorer 1. The orbit reached comparable altitudes. As Explorer 3 completed orbits, the tape recorder captured complete radiation profiles. When tracking stations commanded playback, the data told the full story. Radiation levels started normal at low altitude, climbed steadily as the satellite ascended, reached the detector's maximum of 35,000 counts per second, and continued rising beyond measurement. Van Allen's hypothesis was confirmed. The radiation mechanism became clearer. Earth's magnetic field extends far into space, creating the magnetosphere. This field interacts with the solar wind, a stream of charged particles from the sun. Electrons and protons encounter Earth's magnetosphere. Many are deflected away, but some become trapped. Earth's magnetic field lines guide particles toward the poles at low altitudes, creating auroras. At higher altitudes, particles become trapped in stable regions. They spiral back and forth along magnetic field lines, creating toroidal, donut-shaped belts of trapped radiation encircling our planet. Two distinct radiation belts were identified. The inner belt extends from approximately 400 miles to 3,700 miles altitude. It contains primarily high-energy protons from cosmic ray collisions. These protons have energies from 1 to 200 million electron volts. The outer belt extends from 8,400 miles to 36,000 miles altitude. It contains primarily electrons from the solar wind. These electrons range from 0.1 to 10 million electron volts. Between the belts is a region of lower radiation intensity. The belts vary with solar activity. Explorer 1's elliptical orbit passed through both belts. May 1, 1958, James Van Allen presented his findings at a National Academy of Sciences meeting in Washington, D.C. The scientific community immediately recognized the significance. Van Allen stated, "The Earth is surrounded by belts of trapped radiation of an intensity 1,000 times greater than could have been inferred from any measurement made previous to the flight of Explorer 1. This was the first major scientific discovery of the space age, the first new feature of Earth discovered from space. Media coverage shifted from Cold War competition to genuine scientific achievement. Van Allen became an international scientific celebrity. The radiation belts were quickly nicknamed the Van Allen belts. Informal usage began immediately after the announcement. The scientific community officially adopted the name in 1959. Van Allen himself was characteristically modest. He emphasized that many scientists and engineers contributed to the discovery. The explorer teams, tracking station operators, JPL engineers. But his hypothesis about saturation, his persistence in seeking confirmation, his design of detection instruments earned the recognition. To this day, those invisible belts encircling Earth bear his name. The Van Allen radiation belts protect and reveal. The discovery transformed understanding of Earth's space environment. A new field of scientific research emerged: magnetospheric physics. Universities established research programs studying Earth's magnetic field and its interaction with solar radiation. Subsequent Explorer missions continued the studies. More than 90 Explorer satellites launched through 2011, each contributing knowledge. International cooperation developed around radiation research. Van Allen shared all data openly, fostering collaboration. Soviet scientists confirmed the findings with their own missions. The radiation belts became recognized as both scientific wonder and practical hazard for spaceflight. Every satellite launched since Explorer 1 must account for radiation. Electronics can be damaged by high-energy particles. Satellite designers began hardening components against radiation. Orbital selection considers belt boundaries carefully. Geosynchronous orbit at 22,236 miles sits near the outer belt's edge. Satellites there experience significant radiation exposure over time. Shielding is essential. The International Space Station orbits at only 250 miles, well below the inner belt, minimizing crew radiation exposure. Van Allen's discovery directly influences every aspect of space operations, even today. The Apollo program had to address radiation belts when planning lunar missions. Sending astronauts through the belts required careful consideration. Van Allen was consulted extensively on mission planning. Trajectories were designed to minimize time spent in the belts during translunar injection. Apollo spacecraft passed through the belts in approximately 15 minutes at high speed. The spacecraft hull and equipment provided some shielding. Astronauts received radiation doses, but within acceptable limits. Van Allen's discovery made safe lunar missions possible by defining the hazard. Understanding risk enables managing risk. Science guides exploration. Explorer 1 itself remained in orbit for 12.5 years. It completed approximately 58,400 orbits over its lifetime. The Mercury batteries exhausted after 60 days as designed. The transmitters fell silent, but the satellite continued circling silently. Orbital decay gradually brought it lower. Atmospheric drag, even at those high altitudes, slowly reduces orbital energy. On March 31, 1970, Explorer 1 finally re-entered Earth's atmosphere. 12.5 years of patient observation. A monument to scientific persistence. Answering Sputnik not with propaganda, but discovery. In 2012, NASA launched the Van Allen Probes mission. two spacecraft specifically designed to study the radiation belts in detail. Modern instruments revealed even more complexity. The belts have multiple zones and substructures. They respond dynamically to solar storms. Sometimes a temporary third belt appears. The radiation environment is far more variable and intricate than Van Allen's first measurements could show. But his discovery opened the door. 6 decades later, we're still learning from what Explorer 1 first revealed. Science builds on patient foundations. The political impact of Explorer 1 was equally profound. Just days after the launch on February 7, 1958, President Eisenhower established the Advanced Research Projects Agency, ARPA. It would coordinate American space and missile research. On July 29, 1958, NASA was officially created. The National Aeronautics and Space Administration, a civilian agency dedicated to space exploration. In 1960, von Braun's team transferred from the Army to NASA, becoming Marshall Space Flight Center. JPL transferred to NASA in December 1958. Explorer 1 catalyzed institutional transformation that enabled Apollo, Voyager, Hubble, and Mars rovers. American space philosophy shifted after Explorer 1. The initial impulse was simply to match the Soviets, launch something, anything, into orbit to prove capability. But Van Allen's discovery demonstrated the value of patient science. Pickering stated, "We have firmly established the American foothold in space." General Madaris said proudly, "I wouldn't trade one Explorer for 5 Sputniks." President Eisenhower called it a real contribution to human knowledge. America's brand became quality over speed, scientific return over propaganda, discovery over mere firsts. Even Vanguard eventually succeeded. March 17, 1958. Vanguard 1 finally reached orbit. That tiny 3.25-pound satellite is still orbiting today. It's the oldest human-made object still in space. The failures, TV3 and TV4, were learning experiences. Engineering refined. Systems improved. Vanguard 1 operates no longer. Its batteries exhausted decades ago. But it circles still, a testament to persistence. Failure and success intertwine in exploration. Both teach us. The National Defense Education Act passed in September 1958. Congress appropriated $1 billion for science and mathematics education. Sputnik and Explorer together transformed American education priorities. A generation of scientists, engineers, and mathematicians emerged from this investment. They would design Apollo spacecraft, develop computer technology, advance medicine and communications. Explorer 1's legacy extends far beyond its 58,400 orbits. It inspired millions to pursue science. Discovery creates more discovery. A 84 days from authorization to launch. In those urgent 84 days, von Braun's team built more than a rocket. They built a foundation for decades of exploration. From crisis, patience emerged. From competition, science emerged. From propaganda needs, genuine discovery emerged. January 31, 1958, at 10:48 p.m., a 71-foot rocket lifted a 30-pound satellite and revealed invisible shields protecting our planet, and changed how America approaches space forever. Van Allen studied those zero readings for weeks. The pattern was too consistent for random failure. His intuition told him the instrument wasn't broken, but overwhelmed. That leap of insight, from apparent absence to actual excess, defined the discovery. Explorer 3's tape recorder changed everything. Recording data over areas without ground stations gave the complete picture. The saturation hypothesis became confirmed fact. Earth's radiation environment revealed itself through patient measurement. The magnetosphere protects us. Charged particles from the sun, deflected and trapped by Earth's magnetic field. Those invisible belts, discovered by Explorer 1, shield life below. We live under constant protection we cannot see. Apollo missions passed through the belts in 15 minutes. Trajectories carefully planned to minimize exposure. Van Allen's 1958 discovery made lunar landings possible a decade later. Knowledge serving exploration across generations. Every satellite since must account for radiation. Electronics hardened against particle bombardment. Orbits chosen to minimize exposure. Van Allen's discovery protects every spacecraft we launch. Science from 1958, serving missions today. The little satellite circled for 12.5 years. Transmitters silent after 60 days. But orbital path unchanged. 58,400 orbits, patient witness to Earth below and radiation above. March 31, 1970. Explorer 1 finally descended. Atmospheric drag brought it home. Burning up over the Pacific Ocean. The satellite ended, but its discovery endures forever. NASA was born from Explorer's success. July 29, 1958, a civilian space agency created. Von Braun's team became Marshall Space Flight Center. JPL transferred to NASA. Institutions shaped by one satellite's discovery. American space philosophy changed. Not racing to be first, but seeking to discover best. Quality over speed. Science over propaganda. This approach defined Apollo, Voyager, Hubble, Mars rovers. Vanguard 1 still orbits today. Launched March 17, 1958. The oldest human object in space. 3.25 pounds, circling silently. Failure and success both teach us. $1 billion for education. September 1958, Congress invested in science and mathematics. A generation of scientists emerged. Explorer 1 inspired millions to pursue knowledge. Discovery creating more discovery. "84 days of focused work, from authorization to launch, building a rocket and satellite. Compressed urgency met with methodical care. The work was done right because patience guided speed. The Van Allen probes launched in 2012. 2 spacecraft studying the radiation belts in detail. 54 years after Explorer 1. We're still learning from Van Allen's discovery. Science builds on patient foundations. Zero readings meant saturation, absence indicating overwhelming presence. Van Allen's insight revealed Earth's shields, patient science discovering truth. The belts encircle us still. Invisible protection above. Discovered but unchanged. Knowledge from patience. "58,000 orbits, each one perfect. Predictable motion. Science and physics united. Explorer 1 circling in memory. The data still teaching. discovery enduring. Rest now. Van Allen belts protecting Earth. Invisible shields discovered. Science revealing truth. Peace. The magnetosphere guards us always. Trapped particles spiraling. Earth's magnetic embrace. Protection discovered. Electrons and protons circling. Belts extending thousands of miles. Invisible, yet real. Science reveals. The tape recorder aboard Explorer 3, storing data patiently, playing back truth, technology serving knowledge. Geiger counters clicking, measuring particle by particle, building understanding, patient accumulation. The inner belt from 400 to 3,700 miles. High energy protons trapped. Shielding required. Hazard understood. The outer belt reaching 36,000 miles. Electrons from solar wind, dynamic and variable, still being studied. Orbital period 114.8 minutes. Predictable, mathematical, reliable. Physics governs motion. Trust the rhythm. The wait after launch. 90 minutes of tension. Then confirmation came. Relief and triumph. Pickering, Van Allen, three men holding Explorer high. Iconic photograph. Victory celebrated. January 31, 1958, 10:48 p.m. The moment America answered. Not with size but science. Discovery over propaganda. The Vanguard failures taught lessons. TV3 and TV4 refined engineering. Persistence rewarded. Success followed. Operation Paperclip brought German engineers. Von Braun's knowledge serving America. History's complex threads. Progress continues. Raccoon experiments preceded Explorer. Van Allen's years of preparation. Patient groundwork. Discovery built slowly. The Redstone missile adapted. Military technology serving science. Purposes transformed. Knowledge emerging. Sergeant solid rockets clustering. 11, then 3, then 1. Staging toward orbit. Engineering elegance. Mercury batteries providing power. 60 days of operation. Limited but sufficient. Purpose fulfilled. Four fiberglass whip antennas, broadcasting at 108 megahertz. Signals reaching Earth. Communication established. Temperature extremes in orbit. -40 to +105 degrees. Thermal control essential. Paint stripes functional. Spinning at 750 RPM. Gyroscopic stability maintained. Rotation creating steadiness. Motion enabling precision. The 18.35-pound instrument payload. Maximum science in minimal space. Efficient design. Purpose maximized. Earthquake Valley Tracking Station. California mountains receiving signal. Goldstone has the bird. Confirmation moment. Perigee at 220 miles. Apogee at 1,575 miles. Elliptical path planned. Orbit achieved. Orbital inclination 33.24 degrees, tilted relative to equator. Geometry precise, path determined. The first scrub, January 29. High altitude winds too strong. Safety first. Patience required. The second scrub, January 30. Technical issues resolved. Systems checked. Readiness confirmed. The third attempt succeeded. January 31 at 10:48 p.m. Timing perfect. Mission accomplished. Alcohol and liquid oxygen burning. First stage propellants mixing. Controlled combustion. Thrust generated. Tracking cameras following ascent, documenting every moment. Visual confirmation. History recorded. Telemetry flowing to ground stations. Data streaming continuously. Systems monitored. Performance verified. The cosmic ray background at low altitude. Few hundred counts per second. Expected levels. Baseline established. mysterious zero readings at apogee, puzzling at first, then understood. Saturation revealed. Van Allen's intuition guiding analysis. Pattern recognition essential. Hypothesis forming. Testing required. Explorer 2's failure frustrating. March 5th launch unsuccessful. Setback temporary. Persistence continuing. Explorer 3's tape recorder, crucial. Complete data captured. Confirmation achieved. Discovery validated. The May 1 announcement. National Academy of Sciences meeting. Scientific community recognizing significance. History made. The name Van Allen belts adopted. Official in 1959. Recognition deserved. Legacy established. Magnetospheric physics field created. Universities establishing programs. Research expanding. Knowledge growing. International cooperation developing. Data shared openly. Cold War transcended. Science uniting. Soviet scientists confirming findings. Luna missions contributing. Verification mutual. Truth universal. Electronics hardening developed. Radiation protection essential. Engineering adapting. Satellites protected. Geosynchronous orbit altitude considered. Belt boundaries respected. Placement strategic. Exposure minimized. ISS orbiting at 250 miles below inner belt. Crew safety prioritized, knowledge applied. Apollo trajectories planned carefully. 15 minutes through belts. Speed protecting astronauts. Risk managed. Spacecraft shielding designed. Hull protecting equipment. Radiation doses acceptable. Missions enabled. Explorer program continuing. 90 satellites through 2011. Legacy enduring. Exploration ongoing. Van Allen Probes Mission 2012. Modern instruments revealing complexity. Belts dynamic. Learning continuing. Temporary third belt appearing. Solar storms affecting structure. Variability documented. Understanding deepening. ARPA created February 7. Coordination beginning. Resources focused. Progress accelerating. NASA established July 29. Civilian agency formed. Exploration chartered. Future secured. Marshall Space Flight Center created. Von Braun's team transferred. Army to NASA. Purpose evolved.